Ready, set, go. I want you guys actually all standing up at the boards. Make it a little bit easier to see. All right, so here we go. Let's see what you remember from last time. Where'd he go? My suggestion to you on this would be to use the method we learned, square roots. I'd like to see your method, Joel. It's part of the reason for being up there at the board. Guys, why don't you just jump in and join us right here? We're working on... Not quite. So you've got the plus or minus in there. You just put it in there late. What you could do here is you could actually take both of your answers there and you could check them. I think you'd find that it doesn't quite work the way you were hoping. Yeah. Yeah, you were just late with the...
Am I right?
You're just late with the plus minus is what it comes down to. Yeah. Tell me you were sort of half right. Not all the way though. Interesting. Very interesting.
I got it.
So
We have to do it. Like you would know.
Yeah, then you plug in a positive 7 and a negative 7 for the x.
I think it's like the same as that.
This
It's
appears.
it's 7
Back
over.
in here, you'll find that it takes a slightly different turn. Yeah, interesting. I see a very common theme.
That's gonna be wrong.
So far, no one has
7
the
minus
fully
4 is-
correct answer. But you were pretty close.
Oh my gosh.
So far, I have yet to see.
It's positive 7 and negative 7.
No,
Okay.
sorry. Still have yet to
Are you
see a
sure?
totally correct answer.
No, it's
Well, like
7,
that.
and then you have to find the other number.
Interesting.
This is so.
It is.
So, keep working. I'll give you just another short time here. Yes. We have a correct answer.
Mr.
So
You.
oh, it works. Oh, so it's.
Still, nobody has a correct answer up here at the board.
Okay, well, can you tell me what I'm doing wrong?
I'll tell everybody.
Mr. Anderson.
I think it's about that time. I'm sorry, it's not. Sorry. Okay, check this out. I'll give you a chance to practice more. Let me just remind you of a few things. We'll get there. So as far as showing steps, so as far as showing steps go, hey guys, hey, clearly you guys have learned something, but there's clearly still some gaps, right? Clearly there's still some gaps. Please. Stop moving around. Watch this. Check this out. Everybody, I think, from what I could tell, everybody remembered this. Everybody picked up on this. It was really good. Everybody remembered that in order to solve these, you have to get the squared expression isolated, which it already is. But then everybody square rooted both sides. I think I saw everybody did that. So that's really great. So you square root the left side to get rid of the squared. And then whatever you do to one side, you've got to do the same thing to the other side to keep it balanced. So I think just about everybody remembered that. So that's awesome. This is where we had a mix of people remembered certain things, maybe didn't remember certain things. When you square root both sides, on the numerical side, in this case, that's the 9, you have to remember that there are two different numbers where if you square them, listen, there are two different numbers that if you square them, you get 9. What are the two different numbers?
Positive 3, negative 3.
Plus or minus 3. Don't they both work? Because I'll just do this off to the side. Isn't this true? And isn't this also true?
Yes.
They're both true. And so when you ask yourself, what number squared is 9, there's really two different answers here, right? You're asking yourself, well, what could I square to get 9? Well, plus or minus 3. So some folks remembered this. So I'm going to put x is minus 4 equals plus or minus 3. But I'd say the vast majority of people that remembered that basically saw the plus or minus 3 as something that you just tag on in the end. Does that make sense? Yeah? So like, plus or minus, I don't know, whatever, I'll just throw it on at the end, and we'll call it good. So here's where the answer took a little bit of a different turn. I saw a ton of answers that were basically plus or minus 7. And this is where we had the issue. So here's what you should do. If we're trying to get the x by itself, wouldn't you technically at this point just add 4 to both sides? So then if you keep rolling with this, you would get x is equal to positive 4 plus or minus 3. So let's break this up and figure out how this actually works out. This means x is equal to 4 plus 3, or x equals 4 minus 3. 4 plus 3 is 7, 4 minus 3 is 1, and those would be your two solutions. They would both check and work out just fine. So do you see how the plus or minus needs to show up immediately as you do the square rooting of both sides, right? It's not something you just throw in at the end. As soon as you square root both sides, it's there, and it needs to be dealt with accordingly. It can't just be thrown on at the end. So Jake, with you turned it into a multiplication problem. So it's actually plus or minus root 9, not plus or minus 4. It's plus or minus root 9 plus 4, not times 4. Okay, but I mean, you started off probably a little bit better. I think you're getting a little bit desperate just trying to figure out how to make it all work together. So anyways, a good refresher? See how you do with this one. Head back up.
Come on, G. Bad Steve. Thought I was I do.
See, these are like
Okay, please solve that one. Ready, go.
Yeah.
X plus 3 squared, and I'm looking for exact answers here. I'm not looking for decimal approximations. Looking for exact answers. Hey, listen, please. Talking with folks in the back. There was definitely a lot of incomplete work. Maybe you guys worked together to get there. Again, I just want to show you and remind you how this goes. I think we'll do one more after this. So in order to be able to solve something like this, where you've got a perfect square as part of your equation, what you want to do is you want to get that squared quantity by itself first. So in order to do that, we need to add 5 to both sides. And when I do that, I end up with x plus 3 quantity squared is equal to 14. And now once that squared quantity is by itself, now we can actually deal with the squared and get it out of there so we can get the x by itself. So to do that, I need to square root both sides. This gives me x plus 3 equals plus or minus root 14. I've noticed on this one, if there was any fault that somebody could draw here, I would say, as we look through some of these, I would say right here, the plus or minus should be on the root 14 now, not later. This looks pretty good. Plus or minus should be there now. That looks good. Plus or minus should be there right now. Do you see what I'm talking about? So timing is really important as far as helping you remember. I like that. That looks pretty good. Plus or minus should be there now. Probably should be there. Do you see what I'm pointing out here? Timing is everything. Immediately, as soon as you square root both sides, the plus or minus should be on that numerical quantity. Typically, it's on the right side for whatever reason. Should be there. All right, and then the last step would be this. We need to subtract 3 from both sides. And when I do that, I get x is equal to negative 3 plus or minus the square root of 14. So I remember at the start I said I want to see an exact answer. I don't want to see a decimal approximation. So there is no reason for us to turn to a calculator and figure out what the square root of 14 is and do unless you're directed to do that. If you are, then yeah, sure. I showed you how to do that last time. No problem. Hopefully, but because I asked for an exact answer, you just leave it like that. Now, isn't this actually easier than doing the decimal thing? You just say, hey, negative 3 plus or minus whatever root 14 is. I think it's easy. Okay, do you guys have any questions? All right, I got one more here for you as far as a warm-up goes. So if you guys would return to the board one more time, let's see how this goes with this one.
Yeah. Wait. 0.1? Yeah.
Please let me finish writing the whole thing before you get going.
I know.
That's where it was going to be.
Just call me.
You turn off the squares.
All right, I like that one. Ready, go. Solve would be the instructions here.
Do you want an approximate answer? Or like
No, if it says solve, that implies exact answer. So, yeah, go with exact here. I don't think you wrote the whole question down.
No, I wrote the same thing.
Yeah, I don't think you wrote the whole question down. It's 3.
I didn't see the 3.
Yeah, so I think,
Did I get
Jake,
it
I don't think you saw the
There's
3
a
either.
3 at the beginning. What?
I didn't write the whole thing.
You tricked us.
No, I didn't.
Yes, you added it at the end.
No, I did not. I specifically said wait until I'm done writing this. And then I said after a while I said go. Yeah, so 10. I think you lost the -5. Is that
Oh, I
-5?
didn't see the last one.
Yeah.
Just read it all.
Joel, it's not quite right, my friend. I'm sorry.
Wait, what's 8 times 3? Oh, 20.
Oh, here we go.
Oh, probably these real places because we talked. I'm done. So I like what you did here.
Why not?
So what you want to do? Because you're wrong. I'm going to try to get this square.
It's okay. Did it again. What are you doing, Jake? That Mr.
Okay, there we go. So, hey, listen. I'm going to keep kind of hammering away at this because I feel like I'm getting fairly close to getting across to you, but we're not all the way there yet. Whenever you've got a perfect square quantity like this one, like the other ones we've done so far, like the ones we did yesterday, or Monday, I guess it would be. Listen, your number one goal, I hope you're listening, your number one goal in this process of solving should be this. Isolate the perfect squared quantity. Isolate it. Get it by itself. Definitely, whatever you do, don't make it more complicated, right? Don't like try to simplify it out and FOIL it, or or do some kind of a distributed property. Get the perfect square quantity, isolate it all by itself. So as I walked around and watched and talked with you guys, almost everybody did this, and so this was a good move. So then once you've done that, you get 3 parentheses x minus 8 squared is equal to 15. That was a really good move. Isn't that move designed to try to get the perfect square quantity by itself? But then we had some major issues with the 3. It was like we really desperately wanted to distribute the 3, and you can't do that for a number of reasons. Number one is it's out of order of operations. You can't distribute, you can't multiply through into something before you do an exponent, right? It's PEMDAS, not PEMDAS or whatever, right? Exponents come before multiplication or division. So you can't do that. It's way easier to do it the right way. Think about it like this. That 3, how's that 3 attached to the perfect square quantity? How do you want to do that? So all I have to do here is divide by 3 on both sides, and the 3 factor would cancel with the other 3 factor, leaving us with x minus 8 squared is equal to 5. Grace, I'd like to finish this, and we can go back to a step if there's one you want to go back to. Okay, so then once you've done this, the perfect square quantity is isolated, so you can square root both sides like we've done. So when I square root this side, the square root cancels with the squared. When I square root that side, I end up with x minus 8. And notice I'm going to put it in now, plus or minus square root of 5. So then my final step would be to add 8 to both sides. So 8 plus or minus root 5 would be my pair of solutions for this equation. Okay, Grace, your question.
I don't understand. I still don't understand. You're saying you can't go out of order of operations, but the very first thing you did was add.
So we're doing 2 different things here, like I mentioned. So when I add 5 to both sides, my goal is to solve the equation.
But isn't that your whole entire goal?
It is, actually. So when you do this, it is actually. But when you did this, when you did the thing you did, I'll write it up here. So when you did this, how is that? Now think about it like this. When you were supposed to solve an equation, isn't that another way of looking at that is like isolate the x?
Yes.
right? So when you multiply a 3 in there, aren't you doing the opposite of trying to isolate the x? Aren't you putting something else with the x?
Yeah.
So in that case, you're actually not trying to, your steps are not trying to solve anything. Your steps are actually like simplifying, almost doing like an order of operations question. I mentioned it to you guys last semester at the start. When you were actually solving an equation, in kind of a rough sort of sense, you're actually reversing the order of operations. So like what I pointed out to you, Grace, I think I would still stand by it. When you look at it from this perspective, when you've got 3 times x minus 8 quantity squared, with blah, blah, blah over here, and then your next step is this. First of all, that is wrong. And I can show you numerically if that's what you would like to see. But second of all, I would say that going from this step to this step has absolutely nothing to do with solving an equation. It has everything to do with trying to simplify something into a different form, and that's where you've gone out of order of operations. If you are going to simplify, you have to follow order of ops. If you're going to be solving technically in a rough sort of sense, you're actually reversing the order of operations, which is exactly why I added 5 to both sides to start off with. Here's the bigger picture.
Okay.
The goal is to isolate x. And I would say that by doing something like this right here, you are not shooting to isolate x.
Okay.
You're actually making x slightly more complicated, right? You just multiply the 3 in there.
Yes.
Does that make sense?
Yes.
I want you to get the bigger picture as opposed to trying to like memorize little bits and pieces of something.
Yeah.
Okay. You guys have any other questions? Anything else? Okay, cool. Well, great job with the video. We're like high 80% right now. There's a handful of you that did not complete. And again, if you refuse to do that, I'll just keep putting zeros in there. That's your business. I wish that you would, though. I think there's something to be gained from it. And so what I'd like to do here is kind of segue into that. So if you guys would, we'll practice this a little bit more throughout this week and a little bit into next week, okay? We'll keep practicing for sure. So if you guys would, pop open your notes to 9.2, and we'll take a look at that. And we're going to spend 2 days in this. We'll spend today and tomorrow working on this.
Alright, no, there's a video, that was my bad. I'll watch it tonight.
Okay. Part of the connection is really obvious, and some of it is not as obvious. Like when you see an example like number 3. In the past, have you seen things like this?
Yes.
Yeah, you have. In fact, what I would like to do is I would like to solve this. I would like to work on this with you guys using an old method. And I want to try to connect it with a new method and show you how it all works. So in the past, now this says solve using complete the square. And that was the topic that was mentioned in the video. And so what you might have done in the past, and I think this would be very reasonable, you might have looked at this and said, oh, I'm supposed to solve this. Like, honestly, this question could have been on the chapter or the Unit 6 test, I think. This could have been right off the Unit 6 test. Bless you. What strategy might you have used to solve this back in the Unit 6 test? Yeah, the factoring. Yes, factoring. So let's try that. Let's see if that works here. So if we are going to use this factoring, we'd find AC. What's AC for this one? Negative 12. Okay. And the B is 4. So are there any numbers? 6 and negative 2. Yes. Very good. So 6 and negative 2 work perfect. You guys are so much better at factoring. You've been trying to tell. And so this would factor. We'd go x squared plus 6x minus 2x minus 12. We would then group and add. At this point, have we factored it?
No.
How do we know that it's not factored?
There's the addition between.
Still an addition, yeah. We got to get rid of that. We got to change this over. So I got to factor out my GCFs. So that would be x plus 6. What GCF should I factor out of the second group? -2. Got to be -2. You're right. So -2, like so. And then you factor out your leftovers, x plus 6, x minus 2. Are we solved yet? Right, we're done?
No.
How do we know we're not done? Got to set each factor equal to 0, right? All we've done so far, we have definitely factored this. We've done a good job factoring it, but we haven't solved anything, right? Solving means you found solutions. So I got to set each factor equal to 0, like you guys said. So this would be x plus 6 equals 0, x minus 2 equals 0. So x would equal negative 6, or x would equal positive 2 when you subtract 6 or add 2, respectively, to both sides. So like I said, does that not feel like something exactly like you did in Unit 6 and Unit 7 and Unit 8? All of them? Yeah, I hope it does. So will you guys just remember this with me? Will you remember that the solutions are negative 6 and 2? So I want to show you something a little bit different. So you're about to find out after this that all of the questions like these, all these quadratics that you guys have worked on, have been carefully designed to factor and carefully designed to work out nicely for you. You're also going to find out that almost all the quadratics you might ever possibly encounter are not nicely designed. And so you're going to have to learn some new methods. And so what I thought I would do is I would show you a new method that will work on this, but it'll also work on any other quadratic you might ever encounter. Okay, and I'll show you one of those here in a second. So what I'm about to show you, you would really not have to do with this particular question, but with ones that follow, it would be a technique you might have to use. Does that make sense? Okay, so I want to show you this process. This is that complete the square process that you were practicing with a little bit through the video. So here we go. Are you guys all fans? I think you all are fans of this. Are you fans of step 1 is this? Step 2 is that? Step 3 is such and such? Step 4, you're done? I'm going to give you some very clear steps, and I think you'll hopefully make a connection with what you did in the video. So if you choose to use the complete the square method, here is step 1. Step 1 is add c, or subtract c, or move c to the other side. So I'm going to write this as x squared plus 4x, and then I'm going to add 12 to both sides, so equals 12. And I want to make a special note here. Do you see how I left a gap where the minus 12 used to be? Do you see that? I think that that's a good thing to do, right? So, I can see, I apologize, I see that I've gone a little bit too fast. Let me show you this. So step 1 is move C. Move C. So with it I move C as I go plus 12 to both sides. So that would give me x squared plus 4x. I'm going to leave a blank space where I had that 12, that minus 12, and 0 plus 12, of course, is 12. Does that make more sense? Does that make more sense?
Yeah.
Okay. All right, so step 2. We are going to do some stuff with B. So here's step 2. We're going to do some stuff with B. What is the B value?
4.
B value is 4. And you know what? Let me do this in a little different color. Here we go. B is 4. And based on the video, do you remember what we do with B? Cut it in half. So half of B is 2. And then what do we do with the result? Square it. Right off the video, you cut the B in half, and then you square the result. And of course, that results in 4. Now this is your special number that's going to create a perfect square. This is why this is called complete the square. We're going to create a perfect square quadratic, or perfect square trinomial. So here is what I do with this. This would be step 3. I'm going to add that 4 that I just found to both sides. Okay, so I'm going to go plus 4 right here. And as you guys know, with an equation, if you do something to one side, you got to do the exact same thing to the other side. Hold on, Grace. I apologize. Please don't interrupt. You can't add one thing to one side without adding the same thing to the other side. So I've found that 4 by going half of b squared. I add it to both sides. Grace, look at me. I'm very serious about the don't interrupt thing, okay?
I was just using
You did. No, earlier you interrupted. Go ahead.
Is it always you add 4? Is that just...
So here, yeah, that's a good question. Let me clarify. You don't always add 4 to both sides. Depends on the question. So I'll put it like this, Grace, to just be as general as possible. You add the half of b squared to both sides. Add the half of b squared. So if b was 10, you would not be adding 4 to both sides. Can I show you some other examples a little bit?
Yeah, no, I'm following.
Okay.
I got it.
Okay, so then on the left side, remember this is called complete the square. So we are creating a perfect square. The left side should factor really nicely. It should factor as a perfect square. So let's just see if you can process this in your head. What numbers multiply to be 4 and add to be 4? 2 and 2, right? It's a perfect square trinomial now. So the left side is going to factor like this. X plus 2 times x plus 2. But I would advise you to write it in a slightly different way. Instead of writing it as x plus 2 times x plus 2, it could be written as x plus 2 squared. It's a perfect square, right? So I'm going to write it like that. So x plus 2 squared. The right side is 12 plus 4. Well, that's 16. Now, when you look at that, does that look like what we've been practicing with all morning? Can you make that connection? Look at the board. Look at the board. There's stuff still left up on the board. Do you see how that looks just like some of the stuff we've been practicing? And the perfect square is already isolated. So if I want to get rid of the squared, what would be my step 4?
Squared.
Not square it. Square root it. Yeah, so I'm going to put, for step 4, square root and solve. So I'm going to square root both sides. That gives me x plus 2 equals plus or minus, square root of 16, of course, is 4. And then I would subtract 2 from both sides. This would give me x equals negative 2 plus or minus 4. And then if you want to get exact answers, this actually ties right back into what we started with. X would equal negative 2 plus 4. X would equal negative 2 minus 4. And you remember those answers from the start of this?
No way.
2 and negative 6.
Oh my.
Yes. So this complete the square method, here's the usefulness of this, because somebody that was maybe only halfway paying attention for the last 5 minutes might say, well, gosh, factoring is easier for me because I've practiced that a lot, right? Why would I use this instead of factoring? Well, on a question just like this, I would agree, I would use factoring, but on the question we're about to see, factoring ain't going to work. Bless you. That makes sense? I've asked you this before. Does this seem like something that we need to practice a lot? So we're going to do another couple here today, and we'll spend pretty much most of tomorrow practicing. Okay, so let's move ahead, look at number 4, and this will be a good opportunity for me to show you again, give you a sense of the steps again. Number 4. Let me help you make one connection. If you saw this on a quiz or a test, it says solve. Might you think about factoring? Seriously, I think if it just said solve, you'd be like, oh, cool, I can do this, I can factor. Think about how this is going to work. This is the big, probably a really great connection for you to make. I'm going to use this magic X. It's all going to turn out great. What's my AC? Negative 5. What's my B? Which numbers work? There are really not that many factors of 5, are there? Basically, it's 1 or 5 with some plus or minuses thrown in there. There's no way on earth we're going to be able to get to a place where we can figure out which numbers multiply to be negative 5 and add to be negative 8. So this is a case when this complete the square method really, at this point, has to be used. Does that make sense? In number 3, you could have factored or you could have completed the square. No big deal. Here, you're going to have to complete the square. So let me see if I can clearly spell these steps out for you again. And by the way, I'm making a video right now, and so if later on you're working on your WebAssign and you're like, oh my gosh, I forgot how to do this, there's actually videos on WebAssign. This video will be posted. You got lots of resources and opportunities to use to help yourself understand. Okay, step 1. Does anybody remember step 1?
Yes.
What is it?
Add the 5 to both sides.
Yep, add the 5 to both sides. Move the C. So we're going to move C. So I'm going to go plus 5 to both sides. You guys are right. So this would be x squared minus 8x. And like I said before, this is hardly necessary at this stage, but I always leave a blank spot where the minus 5 used to be. Again, I'd like you guys to do this one with me. Please don't just sit there and watch. That's great. It's better if you're engaged by writing. Okay, so I added 5 to both sides. Step 2, step 1 is move C. Step 2 is do what?
B.
Yeah, do stuff with B, right?
Yeah.
So if you wanted this to rhyme nicely, you could say step 1 is move C. Step 2 is do stuff with B, right? So I'll just put stuff with B. Let's figure out what the B is. So in this case, b is? Negative 8. Agreed. So what do we do with that b, the negative 8? Half it, yeah, times it by 1/2, right? So half of b is negative 4. And then you square the result, and you get 16. Okay. So did you watch the video?
Yeah.
It's what we did in the video. Remember in the video at the end, we basically identified the b as several different times? And I said, hey, let's take that b, let's cut it in half, square the result. Take the b, cut it in half, square the result. So this is step 2. So Lana, and everybody really, there's a couple different levels to this. You can look at this process as, okay, if I can memorize step 1 and step 2 and step 3, and if I can execute those well, I should be fine. Let me help you understand a little bit about why. What we are trying to do is this. Listen, hey guys, this might be really helpful. I was going to say this later, but I'll say it now. Do you remember how at the very start we looked at this? And I said, hey guys, let's try to factor it. And we all thought, well, which numbers multiply to be negative 5 and add to be negative 8? And you all came up empty, right? You're like, this thing doesn't factor. Listen, what we're doing with completing the square is we are trying to take something that didn't factor and turn it into something that does factor. And not only factor, but factor is a perfect square. Does that make sense? So, Lana, that's the why. We're trying to take something that didn't factor. We're going to try to turn it into something that does factor. And the key to doing that is identifying your b, cutting it in half, squaring the result. Make sense? Okay, so 16. 16 is our complete the square number that's going to help us get to where we want to go. So what I do with that 16 is I add it to the left side, and I also add it to the right side. Okay, so once I've done that, then I can factor. I'm going to point out a little trick here in a second. The right side, of course, is 21. The left side, how does that factor? Which numbers multiply to be 16 and add to be negative 8?
Negative 4.
Right, again, that's a perfect square, isn't it? So I'm wondering if anybody can make this connection. There's a special relationship between the factoring that we just did and some of the stuff we did a minute ago. Anybody see anything similar, any connections you can make here? There's something up there that'll make this really, maybe a little bit simpler for you.
They're gonna be the same number.
Something's the same number. I agree. What do you see, Alec?
It's a square root. It was like a square root, so I can just do like square root of x.
Well, we are going to square root. We will. But, so you're forward thinking. I'm kind of backwards thinking a little bit. Will you guys compare this with our factoring? What do you see?
What?
Compare
the thing in the red box with our factoring. Yes, sir?
Negative 4 times negative 4 is 16, then 4 minus 4 is 8.
So when you factor, the number in your factoring should always be the half of b. We'll dive into this a little more deeply tomorrow, but that relationship should always be true. Okay. Anyways, so once you have factored, step 4 is to square root and solve. So I'm going to square root both sides. This is just like what we've been practicing with. When I square root both sides, I get x minus 4 is equal to plus or minus root 21. And then my final step would be to add 4 to both sides. X is equal to positive 4 plus or minus square root of 21. Okay, so this is like a very consistent process, very consistent strategy of step 1, step 2, step 3, step 4. You've seen it twice. I hope that you have been participating. I think that you have. My thought is now we've got about, 8 or 9 minutes to go in our class. I'd like to see if you guys can take a little bit of a shot at this at yourself. Okay, at your tables, work together. You got all the steps laid out right in front of you. They're right up there as well. Let's see how you do. I'll give you a few minutes to try this, and we'll try to sum it up here at the end. So move on to, I think, number 5, if I remember right. So number 5, yes, number 5 will work out great. And so the fact that I walked around, I didn't get to everybody. I walked around, I saw some really good answers, some processes that looked great, is very encouraging to me. I hope it is to you as well. All right, so this says solve using complete the square. I didn't ask you to think about does this factor, but if you did, and you ask yourself, well, which two numbers multiply to be -2 and add to be -6, aren't you going to come up empty again?
Yeah.
There are no such numbers. So if there were, listen, please, guys, please don't pack up yet. It's really distracting to me when there's like 10 different backpacks being zipped up at the same time. Hey, I really mean that. Please don't. So if this didn't say use complete the square, we probably would just use factoring if it was factorable, but it's not. So we're going to use complete the square. Reviewing the steps, step 1, move the C over. So as I peeked over shoulders, I saw just about everybody had that. That's a good first step. Step 2 is to identify your B. Our B is -6, and so half of B is -3, and the result of that squared is 9, right? What do we do with that 9? Add it to both sides. You are correct. So I'm going to go +9 and +9. So what I've done here, we're going to find out in a second, is I've gone from a trinomial that didn't factor, and I've transformed it into one that does, enabling us to use all these skills we've been practicing before and today. So the right side is just 11. The left side will factor as x minus 3 squared. You can arrive at that by using a magic x, or you can realize, you know what, it's a perfect square because I turned it into one. And the number in the factoring will always be that half of b. And then finally, the last steps are to square root and solve, giving me x minus 3 equals plus or minus root 11. Final step would be to add 3 to both sides, which gives me x equals +3 plus or minus the square root of 11. I see some faces that were like, I think I got that. Yes. Hey, we'll practice some more tomorrow. Hope you have a great day.
So can we just write that as the answer? Do we have to write like x equals 3 plus root 11 and then x equals 3 minus